Welcome to the webinar Introduction to Urban Flood Warning by OTT HydroMet. My name is Hannes Tietz and I am product manager for OTT HydroMet located. As many of you, I'm working remotely at the moment, so I'm living in the very south of Germany in Sonthofen. I'm product manager for hydrology sensors, and today and before we start with the webinar, I want to give you the opportunity to ask questions during that webinar. So you are all muted during the webinar. So if you have any comments or questions, you can use the questions field in the GoToWebinar software. Just type in any question anytime it comes to you, and I try to either directly answer the question, or we will have a question and answer session at the end of the webinar where I will read out all the questions and then try to answer them. So today this webinar is, as I said, an introduction to the flood warning in urban. Start with some introduction slides, then an overview of the process, how to make cities and areas flood proof, always from the view of a monitoring network. And then what are the components of a flood monitoring network? A selection guide of what to use. So what components are better than others for what solutions. Then some OTT HydroMet solutions that we did over the last few years, and then as a question and answer session at the end. Yeah, as you are all aware, climate change is there, and heavy rainfall events have become more frequent in recent years, and especially in not known as flood hotspots. So many cities or areas experienced heavy rainfall events and flood events where such things never occurred so far. So a lot of mayors or responsible persons in the city drainage and fire brigades and civil protection must adapt to this new events, and they need to search for solutions. And so we try to help you. We try to help these people out by offering monitoring solutions. So if you decide to, or if you want to make your city, your area flood proof, and you start the process of building up a monitoring network, you need to start with evaluation and what's out there. Then you need to include all the actors, all the stakeholders to your team, and then include them all to the process. You need to then define a monitoring network, select the appropriate technologies. Then very important, not just installing technology and setting up a measuring network, you need to when will alarms be triggered and what measures come then. And then after event is before the event. So every time an event occurs, you need to adapt and improve. So see what worked, what didn't work, and then start from the beginning. So let's dive into those points a little more. As I said, you start with assessing the situation. So that means first you start, what risks are there? Then who should be alarmed and when should who be alarmed? yeah, if perhaps you also want to track long-term trends, or you just want to track short-term events, who knows, you need to assess that at the beginning. Perhaps you also want to test existing measures. So perhaps infrastructure measures that you have already, perhaps you want to test if they work. Or you just want to monitor retention basins or whatever. So first you need to assess this. You need a flood monitoring network. Then you need to define the network. So first you need to know where are the critical areas, what are the hotspots. To help there, risk maps can help. So one first step before starting with defining a monitoring is that a risk map, area risk map is created. Then you need to know where is the flood potential and where are critical points, sensitive areas like car garages or any overtop. Also, people could be hurt, or there could be huge damage to infrastructure or any goods. Points, those hotspots and sensitive areas need to be determined. Then it needs to be determined what parameters will help you to minimize the risk, or to also recognize where to recognize early enough what's coming. So there are different parameters available that can be measured. Definitely the first parameter is rain sensors should be spread around your area. Then, of course, water level sensors. There are also water flow sensors, and technologies for that. So first you need to decide what parameters you need. So precipitation, water level, water flow, and then you need to select the right technologies. And there are different technologies out there, and here is just a quick overview for precipitation and level. I will go into detail after that, so there will be some more slides helping you decide one. There are obviously more parameters to measure, like water flow, like perhaps webcams. But in this webinar, as this is more an introduction, I want to concentrate on the critical few and not to overload that here. So if the monitoring network is defined, technologies are there, the alarm conditions need to be defined. So that means you need to decide on thresholds. You need to decide on what thresholds, who gets informed. So not everybody should be informed perhaps at the first threshold. So if the risk is pretty low, so there perhaps you only want to inform few people, and then it goes on. So who gets informed when, and then very important, what should be done when. So what should be done when threshold X is triggered. That all needs to be defined before the events, and the better the plans are here and the better the alarms are, the higher is the chance that you can do something or can minimize the threat of an event. So there's a lot of planning involved. And then, of course, after an event, you need to adapt and improve. So did you receive the data on time? So was the data good? Were the alarm conditions right, or were they wrong? and do we need additional measuring stations, additional gauges? This all needs to be assessed, and then yeah, perhaps you need, after the event, start with a new measuring station. So far as an introduction, now, as I said, I want to start with, or want to present you a little bit of a selection guide. So what are the different components of such a measuring network, and when do I use what? So a flood monitoring network most of the time in general looks pretty similar. So you have out in the field the measuring station, which is represented here. A measuring station consists of sensors. This could be in the water, the sensor could be out of the water, so contactless, and those sensors are then connected to a data logger. The data logger is the heart of the station, so it collects the measuring data, it powers most of the time the sensors, and it transmits data. The whole thing is either powered by solar or by mains power or by battery. So here in that case you have a solar panel, and then the data logger transmit the data either via mobile network, via satellite, or via any other LAN network to a software solution that collects the data and that also can then alarm the stakeholders. So either the software can alarm the stakeholders, but also the data logger directly can alarm stakeholders. So it needs to be decided case by case what makes more sense. Perhaps also the first responders get alarmed by the data logger, and then the public gets alarmed by the software. So that could be one way. In addition, what's more and more important and used more and more is the use of webcams. So also the webcams get directly connected to the data logger. I want to concentrate on two main parameters. One is the level and one is the precipitation. So the alarm level gauges are most of the time installed at critical places, critical hotspots. The precipitation sensors are often installed more in the catchment areas. So as I said, there are different technologies for measuring water level, and one technology is the radar level sensor. So as you see here, that's a contactless measurement. The sensor, it's here, that's the little gray one, is often installed on bridges, and it's looking down to the water surface. The advantages are pretty clear. As it's a non-contact measurement, there are no damages during flood conditions. So it's not in the water, it cannot be destroyed by debris. The installation, as long as there are bridges or structures available, the installation is pretty simple. It just needs to be installed up on a bridge. It's out of the water, nobody needs to get into the water. But it's important to know that these sensors need to be installed above the flood level. So if they get flooded, they not necessarily get destroyed by water because they are watertight, but first, they do not measure anymore. And second, they can be destroyed by mechanical force. So if a tree or whatever, a rock hits the sensor, it gets destroyed. Also, it needs to be taken care during the installation that the radar beam can be reflected by other obstacles that lead to wrong measurements. So the measuring path, so the radar beam there may not be any obstructions in the radar path or radar beam. So that needs to be clear. If that's okay, the radar level sensor is always a very good solution to measure water level. And then there's also the possibility to measure the water level directly in the water by using pressure level sensors. You see it here. They are small stainless steel or often stainless steel sensors. And you see one to the very right. That's how they look like. They always need to be covered by water to measure. There's a small pressure cell in the front. They are very accurate. They measure directly in the water. They also measure the water temperature. And the sensor itself is often very cost effective. And then with a cable, they are connected to the data logger. So it's important to know, as I said, that those sensors are always covered by water. Otherwise, they don't measure. Of course, for flood measuring stations, they are just covered by water during flood events. So that's also okay. So also some rivers just have water during flood events, so that's okay. But during the event, when it's interesting, the sensors need to be covered by water. Of course, as they are installed in the water, they can also be damaged by debris. So it needs to be taken care that they are protected. And as they are in the water, they can, of course, get dirty, cleaned depending on the site conditions. So it could be that it's enough to clean them once per year. If it's a very dirty site with a lot of sedimentation, it could be that they need to be cleaned more often. And depending on the site, it's easy to install them or it's more difficult to install them. So if I look at both technologies, it's always the situation you need to look at the situation, what makes more sense, if it's better to install a radar level sensor or a pressure level sensor. Either one could be more cost effective, depending on how difficult the installation or how easy the installation is. So if you have difficulties or if you need support there, the OTT HydroMet experts can always support you in taking that decision. Then I jump here to the left to the all-in-one solution. So it's also possible to have the pressure level sensor in an all-in-one solution. It's at OTT HydroMet, this is the OTT Ecolog 1000. So as I said before, a station is always a pressure sensor connected to a data logger and then a power supply like a solar panel and data transmission. In that case, it's all in one. So you have the pressure sensor, it's connected via cable to the communication unit. And that communication unit is the battery, which lasts for 1-2 years, the modem, the data logger. So it can be easily installed in a well. So it has the 2-inch diameter up here. It's not too big, so it can be easily installed. No additional infrastructure is needed. Also very discreetly installation, which is important against vandalism in urban areas. But very important, the communication unit always needs to be above the flood level because it cannot transmit if it's covered by water. As I said, more and more important are also the webcams. So webcams help you to see exactly what's happening on site, and it's also very important to document events so that in case of after events, if there are issues with insurance or stuff like that, it's always good to have a documentation or a visual documentation of events. It's important to know that webcams can also work at night with infrared mode, and they can also be controlled by the data logger. That means if you only have solar power, then you only switch on the webcam in case of an event or as soon as a threshold is triggered, so that you are in a kind of power save mode and the webcam is only active in case of events. So this is possible with the data loggers. Yeah, then the second parameter I want to talk about is the precipitation. So there are different technologies for measuring rain and precipitation, and I want to present to you the most common ones. So one is the weighing precipitation gauge that you see here on the left. So at OTT HydroMet, this is the OTT Pluvio that's available in a small version, the OTT Pluvio 2S, and it's available in a larger version, the OTT Pluvio 2L. The difference is, or I will come to the difference later. So what's the principle? In the end, you have a highly precise weighing system down at the bottom. And on this weighing system, there is a bucket that collects the precipitation. And so the precipitation is the weight of the bucket, the content of the bucket is permanently measured. And so it precisely captures rain events, and especially it also captures precisely heavy rain events, so high intensity events. As there are not really mechanical parts in there, so nothing that moves besides the weighing system, and that's pretty good hidden. So this system is almost maintenance free. The only thing what you need to do is that you need to empty the bucket before it's full. And so that's one of the main difference between the smaller version and the larger version. The smaller version has a small footprint, of course, but not that high content. So perhaps you need to, depending on where you are in the world, need to empty it twice or 3 times per year. And then the larger one, you perhaps only need to empty it once per year. So that always depends on your local situation, how much rain you have. So to get a very good accuracy in your monitoring network, we recommend that every monitoring network should at least contain one pluvio to have the highest accuracy. A cheaper solution and a very common solution, or a solution that you see very much across the world, is the tipping bucket rain. The collection area is up here. So here it's the rainfall going in. And then there's a filter, and the precipitation or the rain is collected and flows down to a small, let's say, spoon. And whenever the spoon is full, it tips down and creates a signal and is filled again. So those signals are counted, and by those signals, the amount of rain is calculated. So as you see, those sensors are pretty small. They have a small footprint. They are cheap, so cost effective. So you will find rather cheap solutions out there in the market. But the disadvantage is that they need to be maintained regularly, as the filter up here can be blocked by insects or leaves or any kind of dirt. And then, of course, rain events are not captured precisely anymore. And also, due to the system, due to the technology, heavy rain events are not captured precisely. So it's, if you have really high rain events or heavy rain events, that could create issues with that technology. And then there is a new technology coming up in the last years. It's the Doppler radar precipitation gauge. So it's very small, no mechanical parts, maintenance free. and also cost effective, but the accuracy is way lower than compared to the other two systems. So what this system is used for is to tell you if there is a heavy rain event or not, or if there. So you could spread those sensors across your region to capture where is the highest intensity of rain, where does the thunderstorm go down, but it's not that good as the other two to precisely capture the event. So much for the precipitation sensors. So, and then the sensors are connected to data loggers and data transmission systems. So what you see here on the right is a OTT Hydro system. You see the OTT NetDL, that's the data logger. That's the power control unit. Up here you see antenna. And then there are different ways for data transmission. One is mobile data transmission. It's what you know from your cell phone. So it's ideal for reliable data transmission, has a broad bandwidth. There's two-way communication possible, so you could also connect to the logger from remote. But of course, you need to check if the network is available on the site. Then there's data transmission. Oh, sorry, there's still a German term. There is data transmission via local area network, via LAN. So important to know, in cities there is often infrastructure for data transmission available. So for traffic light control or for any kind of infrastructure. So perhaps you could leverage the systems to connect your data loggers to that. So we've seen cities that do that with their. And then there's also the possibility via satellite. So it has, of course, a full global, it's available everywhere. It also allows for two-way communication, and you're not reliant on existing infrastructure. So that is available everywhere. Then the station needs to be powered. There are mainly two, let's say three ways of powering a station. One is solar power. Of course, you don't need existing infrastructure. The solar panels could also be station setup. But two things to mention: they always need a buffer battery. Of course, in the nighttime there is no sun, and they should be protected from vandalism. This is a huge issue in urban areas. That case is, of course, mains power, but that is not always available. Also, for mains power, you always need a buffer battery in case of a blackout. And what's also possible, a solution that I have seen, is that the data loggers get powered by street lights. And of course, the street lights are only active during the night. So in the nighttime, the buffer battery is by the street lights, and during daytime, the system is run by the battery. Then, of course, as I said before, the station could be completely battery powered, mainly for the all-in-one solution, so the Ecolog 1000. So that's then the station. And from the station, the data is transmitted to a software solution. Mainly two technologies out there. One is cloud hosting and the other is local data hosting. Cloud hosting means that the complete service, so data receival, data visualization, data storage, is provided by a service provider, could be OTT HydroMet. So you do not need your own infrastructure, and you have access to the data from anywhere via PC or your mobile phone. So it's independent of existing infrastructure, and the installation cost is almost zero, depending on the service provider. You could also host the data on your own. That means you have the data in-house. You don't need to pay regular fees. And you could have the possibility to do network management. So HydroMet, which is installed locally, so on your own system, would offer the possibility to remotely manage your complete data logger network. But of course, you need to set up and maintain your own infrastructure, and it also needs to be fail-safe during events. So the data should be, the system should be available during events when it's most important. But before you decide on what to do there, consider your IT guidelines and talk to your IT. So often the IT guidelines in your organization do not allow one or the other system. So some IT guidelines don't allow cloud hosting, some don't allow that any data logger does contact or is given access to your local system. So either way, talk to your local IT department. Then we are coming closer to the end with solutions that HydroMet provided in the past, and solutions, or how can HydroMet support you setting up your flood monitoring network. By providing workshops and training courses to select the suitable measuring sites and the appropriate technology, or we could also do site visits with you to decide what technologies and what solutions would fit best. We also provide the measuring technology that has just been presented for precipitation, water level, flow. We also provide IP cameras, and also the software for managing the data and doing alarm management. And on the right, you see some examples. So here, the Pluvio for precipitation, a station for measuring water level and water flow, and here a pressure level sensor directly in the water. And here's also an example from Austria. This is a rain retention basin that you see on the left. And here you see the system with the water level measure. Here is the battery, and it's all solar powered. And connected to it is also the Pluvio 2L. So as I said before, this is the larger one of the precipitation measurement sensor. And what's special about this station is that this is all available to the public. So the city in that case decided that the money that the taxpayer paid, so also the citizens should be available to see where it's spent. It's explained here on that platform what's done in their flood warning network, and people can also take a look at the sensors. Of course, the cabinet is usually closed and cannot be accessed by the public. Another for a gauging station in an urban area. It's a solar-powered gauging station with the RLS, so with contactless level measurement. And you see on all made vandalism proof. So the cabinet has an additional steel frame to protect it. The solar panels are installed very high. Also, the RLS is covered with additional steel sheets. So this is also a possibility. And also here is a webcam connected to the data logger. The city of Graz in Austria is also using our technology. So here you see the measuring station. And what they do is they host their own server. So they host their own Hydras 3 server and use this server to provide data to the civil protection, to publish the data for the public on a website, and also to manage their measuring stations remotely. The city of Bonn is also using OTT technology, and what I said before, they use existing infrastructure by the traffic control system. So they jumped on an existing system to transmit that data. So that is also a possibility. And then they also publish the data on the web so that the public has access to it. Yeah, and that's already it for this presentation. So here some more example of measuring stations. So if you have any questions, please use the question field and type it in, and I try to answer them as good as possible. So one first question here, is the Hydra 3 server like a cloud server? It requires a subscription fee. No, the Hydra 3 server is operated by the customer. So the customer needs to provide their own infrastructure and technology, so his own. On this server, Hydra 3net is installed. It's a one-time fee, and then, yeah, the customer operates the software and the server on his own. So Hydra 3 server and Hydra 3net server does not require a subscription fee. Then another question, the pressure level sensors that are installed in the water, are they saltwater proof because of cities that are at the sea? And yes, the sensor material is very high quality stainless steel that's also used by Rolex, and this is saltwater proof, so we have very good experience there. So what type and model of IP camera webcam are supported by NetDL, Sutron, or Sutron expert data loggers? So the IP cameras are only supported by the OTT NetDL at the moment. And what's important that it is an IP camera. So the IP camera would be connected with a LAN cable to the data logger. So that's in the end the important thing. We have a list of cameras that are tested with the NetDL, and we also have cameras in our portfolio that work well with the NetDL, but in the end, every IP camera that could be connected with an IP cable, with a LAN cable, is possible to be connected. Then another question, before we have seen the odd pluvio, so the precipitation gauge that is public available, isn't that a problem? Yes, of course, that's perfect for highest measuring quality. So if the sensor is really just used for measuring events and not measuring precipitation day by day for statistical reasons, it's okay, but usually you would prevent people from being to access the sensor. So usually people should not have access to the sensor. yeah, again, back to the webcam, as I said, the webcams can at the moment just be connected to the OTNet DL, so not the expert data loggers. Are there any differences regarding requirements for location of different types of rain gauges, weighing, tipping bucket, radar, trees and buildings? So in the end, not. Yeah, so there are, of course, requirements of how a precipitation sensor should be positioned. Of course, it should not be under trees or close to trees, and of course, yeah, as far away as possible from any obstructions. But in the end, that doesn't change what technology you use there. Also, a quick comment: if you are more interested in precipitation measurement, there are also webinars in this series during the COVID-19 crisis that only cover precipitation measurement and especially the odd pluvio. So if you are interested in precipitation measurement, you are invited to also join this webinars to get a more in-depth knowledge about that sensor technology. So are there any more questions? Of course, if you have questions after that session, you can always write us an email, contact us. So we are always there to help you. And also, if you want to show that webinar here to your colleagues, to others, there will be a recording of that webinar that will be provided to you, so you can also share then this webinar with others. What is the life cycle of pressure sensors? Another question. So we have the experience that our pressure sensors, so the OTT PLS, for example, or the OTT Ecolog, have a lifetime of 5 to 10 or even more years, depending, of course, on the site conditions. But usually, so we expect a lifetime of 5 to 10 years. Okay, so if there are no more questions, I thank you very much for your attention. Have a good day, stay safe, stay healthy, and yeah, see you on the next webinar. Bye.